There's a machine right now, further from home than anything humans have ever built, and for 138 days, it forgot how to speak. Not how to listen. It could still hear us. Every signal we sent still reached it, 22 and a half hours later, crossing 15 billion miles of absolute dark. But when it tried to answer, what came back wasn't language anymore. It was noise. A steady, endless, meaningless hum, arriving on schedule, carrying nothing. Somewhere out past the edge of the solar wind, the most isolated object ever created by human hands had gone quiet in the one way nobody had prepared for. It hadn't died. It hadn't stopped. It was talking. Just not in any language anyone on Earth could read anymore. And the people responsible for it had absolutely no idea why. This is the story of what happened next. Not a legend. Not a rumor stitched together from anonymous sources and vague quotes from scientists who may or may not exist. This is what actually happened to Voyager 1 in the winter of 2023. And it is stranger, tenser, and more quietly terrifying than almost anything fiction could invent. To understand why this mattered so much, you have to understand what Voyager 1 actually is. Launched in 1977, it was never built to last this long. Nobody designing it in the 1970s expected it to still be transmitting data in 2023, let alone still be the most distant human-made object in existence, currently drifting through interstellar space at over 38,000 miles per hour. It has already left the heliosphere, the bubble of charged particles our sun blows out around itself. It is, in the truest sense, no longer in our solar system's backyard. It is outside. It is in the space between stars. And here's what most people don't process when they hear that fact. There is no rescue mission. There is no repair crew. There is no possibility ever of a human being physically reaching that spacecraft again. Whatever goes wrong out there stays wrong, unless a team of engineers, working with instruments that are now older than most of their own careers, can diagnose and fix it from a distance so vast that a single question and its answer take almost 2 full days round trip. Think about what that means for a second. If something breaks tonight, you will not know if your fix worked until the day after tomorrow. Every attempt is a 2-day roll of the dice with a machine you can never touch again. So, when Voyager 1 started sending gibberish in November 2023, this wasn't a minor technical hiccup. This was the nightmare scenario the mission team had quietly feared for decades finally arriving. Here's where it gets worse. The problem wasn't that Voyager 1 stopped transmitting. If it had gone completely silent in a strange way, that would have almost been simpler. A total loss of signal at least tells you something specific failed catastrophically. What actually happened was crueler than silence. The spacecraft kept transmitting a perfectly clean, perfectly steady radio signal on schedule, exactly as it was supposed to. The carrier wave was there, the heartbeat was there, but the data riding on top of that signal, the actual information, the science readings, the engineering telemetry, the status reports that tell engineers whether the spacecraft is healthy, all of it had turned into what engineers described as an unreadable repeating pattern. Not random noise exactly, not clean data either, something in between. A machine that was clearly still alive, clearly still trying, but had lost the ability to say anything that made sense. Read that again. It wasn't dead. It wasn't broken in the way people imagine broken. It was awake, aware enough to keep its schedule, and yet somehow incapable of forming a coherent sentence. If you want an image for it, imagine calling a loved one from across the world and hearing their voice on the line, steady, breathing, present. But every word that comes out is scrambled syllables that used to be language and no longer are. For the team at NASA's Jet Propulsion Laboratory, the people who have spent literal careers keeping this single spacecraft alive, this was the beginning of one of the most stressful diagnostic operations in the history of deep space exploration. The suspect, they quickly realized, was a piece of hardware called the Flight Data Subsystem, or FDS. Think of it as one of Voyager's 3 onboard computers, the one specifically responsible for taking raw information from all the spacecraft's instruments and its engineering sensors and packaging it into a format that can actually be transmitted back to Earth in a usable way. If the other computers are the spacecraft's memory and its reflexes, the FDS is something closer to its voice, and its voice had broken. But here's what should terrify you about the scale of this problem. This isn't a computer you can simply replace. There is no backup FDS on Voyager 1. There never was, because in 1977, nobody building this thing imagined it would still be transmitting from interstellar space nearly half a century later. If the team could not find a way to fix this failing, aging, irreplaceable piece of hardware, using nothing but code sent across 15 billion miles, that would very likely mean the end of the entire Voyager 1 mission. 46 years of continuous operation, the only spacecraft to have ever directly sampled interstellar space, silenced not by some dramatic cosmic event, but by the quiet, grinding failure of hardware simply reaching the end of what hardware can endure. And this is where the story stops being a technical footnote and starts becoming something closer to a hostage negotiation with physics itself. Every single test the engineering team wanted to run had to be written, checked, triple-checked, and then sent out into the dark. And then they had to wait. Not minutes, not hours. A full day, sometimes closer to 2, just for a command to arrive and for any response, if there was one, to come back. Imagine trying to debug the most consequential software problem of your career on a computer you built when Jimmy Carter was president, using a manual that is decades out of date, where every single test you attempt costs you nearly 2 full days regardless of whether it works. There is no rapid iteration here. There is no trial and error in the way modern engineers are used to. Every decision has to be close to right the first time, because you do not get to fail fast. You fail slow, and you fail expensive. And the clock that's running isn't measured in minutes. It's measured in a machine's remaining finite lifespan. Think about the psychological weight of that. Somewhere in Pasadena, California, a team of engineers is staring at data that shouldn't exist yet, based on a command they sent almost 2 days ago, knowing that whatever they decide to try next, they will not find out if it worked until the day after tomorrow. And overhead, silently, without any drama, without any warning, is the possibility that this could simply be the end. Not an explosion, not a dramatic failure, just a quiet transition from working spacecraft to permanently unreachable piece of debris, forever tumbling deeper into the dark, forever unreachable, its last coherent words already spoken months earlier without anyone realizing they were the last. For months, that was the reality. November slipped into December. December slipped into the new year. Voyager kept transmitting its steady, meaningless hum, like a person trapped behind glass, mouthing words that never quite form. The team tried command after command, each one a roll of the dice separated by nearly 2 days of silence. And each time, the answer came back the same. Nothing readable, nothing they could use. Just that same eerie pattern noise, proof of life without proof of understanding. What most people watching this from the outside never fully appreciated is what was actually happening underneath the surface of the story, in the parts that never made headlines. This wasn't a single problem with a single obvious fix. It was closer to detective work performed entirely through inference, an investigation where the only witness is a machine that can no longer speak clearly, located somewhere no human will ever visit again. The team began working through the memory of the FDS itself, chip by chip, piece by piece, trying to isolate exactly which part of this ancient computer had begun to fail. And in March 2024, nearly 4 full months after the gibberish began, they finally caught a break that changed everything. On March 1st, the team sent a specific command, sometimes described informally as a poke up to the spacecraft. Not a fix, not yet. Just an attempt to get the FDS to reveal something about its own internal state. A diagnostic readout, a kind of confession from the machine about what exactly was happening inside it. And then, as always, they waited. 2 days later, on March 3rd, something changed. Engineers monitoring the incoming signal noticed that one particular section of the data stream looked different from the meaningless pattern they'd been staring at for months. It wasn't fully readable yet, but it was different. And different, after 4 months of identical static, felt enormous. This is where everything changes. It took 4 more days of painstaking work, engineers poring over this new signal, trying to understand its structure before they cracked it. And what they found, on March 10th, was something almost poetic in its implications. The signal wasn't gibberish after all. It was a complete readout of the entire memory of the flight data subsystem. In other words, in its own strange, broken way, the spacecraft had finally answered the question engineers had been silently asking it for months. What is wrong with you? And it had answered by handing over everything it knew about itself, the entirety of its own internal code and status, all at once, like a patient finally regaining just enough clarity to hand a doctor their complete medical history. Buried inside that memory dump, the team found what they'd been searching for since November. A single chip, responsible for storing a portion of the FDS's memory, had failed. Not catastrophically, not violently. It had simply stopped working, the way hardware built in the 1970s eventually does, after enduring cosmic radiation, extreme cold, and the sheer grinding passage of nearly half a century in the most hostile environment human engineering has ever operated in. That one failed chip was enough to corrupt the code the FDS needed to properly format its data, which explained everything. Why the spacecraft was still alive, why it kept its schedule, and why for 138 days everything it tried to say had come out broken. Now here comes the part that should genuinely humble anyone who thinks modern engineering is only about brute force and unlimited resources. The team could not replace that chip. There would never be a hand that could reach out and swap the hardware. The only tool available to them was code, written and sent across 15 billion miles, with each attempt costing nearly 2 days just to learn whether it had worked. Their solution was to take the affected code, the instructions that had been stored on the now dead chip, and relocate it. Split it into pieces and store those pieces elsewhere in the FDS's remaining healthy memory. essentially rewriting the spacecraft's own internal map of itself. From a distance, no human being will ever travel. On hardware, nobody currently working on the problem had personally designed. This is not chaos. This is not luck. This is decades of institutional knowledge, patient methodical diagnosis, and a level of technical discipline that most people will never witness, applied to a machine that is, at this very moment, still traveling further away from every single one of us with every second that passes. In April 2024, the fix for part of the code went up. And then, after the now familiar excruciating wait, Voyager 1 responded. Clean, readable engineering data for the first time in 5 months. Not gibberish, not that eerie patterned hum, actual coherent information, confirming the spacecraft's status, arriving exactly as it should have all along. Weeks later, the science instruments came back online too, restoring humanity's only direct, real-time observational post in interstellar space. Sit with that for a second, because here's where the story stops being about hardware and starts being about something much larger. For 5 months, our only physical presence beyond the edge of the solar system had effectively gone mute, and there was a real, live possibility that it would simply never speak again. Its last useful transmission already sent and gone before anyone even realized the clock had started. And it was saved not by some dramatic last-minute miracle, but by patient, unglamorous, methodical work performed by people willing to wait 2 days between every single attempt for months, without knowing if any of it would work at all. But here's the part almost nobody talks about, the part that should genuinely unsettle you if you actually think it through. Voyager 1 is not fixed the way your phone gets fixed. It is patched. It is held together by a workaround, a rerouted piece of memory sitting on hardware that is now, conservatively, past its expected working life by an entire human lifetime. The chip that failed will not be the last one to fail. It cannot be. Every year that passes, Voyager 1 loses a little more power, and NASA is forced to make increasingly difficult decisions, quietly shutting down instrument after instrument, not because they're broken, but because there simply isn't enough electricity left on board to run them all. In 2023 alone, ahead of this entire crisis, engineers had already made the call to permanently power down one of the spacecraft's remaining science instruments purely to conserve the dwindling energy from its plutonium power source, a power source that has been quietly decaying since before most of the people currently monitoring it were even born. Think about what that timeline actually means. Every single year, this spacecraft gets a little weaker. Every year, the margin for another catastrophic failure, like the one in 2023, gets a little thinner. The engineers who fixed this crisis in 2024 know, better than anyone on this planet, that they were not solving Voyager 1's problems permanently. They were buying time. They know, with something close to certainty, that another failure is not a possibility. It is an inevitability. The only real question left is whether, when that failure comes, whether it's next year or 5 years from now, there will be any workaround left to attempt at all. NASA's own projections currently show a mission budget plan to keep supporting Voyager through its 50th anniversary in 2027. What happens after that is genuinely, honestly uncertain. And here's the detail that turns this from a technical drama into something almost unbearably human. Voyager 1 is not simply a science instrument. Bolted to its side is the golden record, a physical disk containing sounds and images of Earth, greetings in 55 languages, music from across human history, a deliberate, hopeful message assembled in 1977 by a team that included Carl Sagan, meant for anyone or anything that might someday find it. For nearly half a century, that message has been drifting further from home, carried by a machine that very nearly lost the ability to tell us it was even still alive. Every single time the spacecraft goes quiet, even briefly, even for a diagnosable and fixable reason, it forces a question nobody really wants to answer out loud. What happens to that message, to that record of us, the moment nobody is listening on either end anymore? Because, make no mistake, this fix does not mean Voyager 1 is safe now. It means Voyager 1 survived this particular failure. The dwindling power, the aging, irreplaceable hardware, the sheer, brutal 138-day silence engineers just lived through, none of that has gone away. It has simply been pushed slightly further down the timeline, waiting. So the next time Voyager 1 goes quiet, and every engineer on that team will tell you privately that it will there be enough power left to even attempt a fix? Will there be enough working memory left to reroute the code one more time? Will there be a team on Earth, decades from now, with the specialized, almost archaeological knowledge required to speak to hardware this old, this alien to modern engineering, still willing to wait 2 days between every desperate attempt? And somewhere, out past the edge of everything we've ever mapped, still carrying humanity's message to the dark, still transmitting on schedule, for now, Voyager 1 continues on, alone, aging, and closer than it has ever been to a silence that, this time, nobody will be able to fix.